For this lab this week, we are going to be talking about volume and density in a couple of different ways. And one thing you're going to do is you're going to have to be able to find the volume of a sphere. So this is my sphere. This is the ping pong ball you'll be using in your lab kit, and we're going to find the volume of it. The volume of a sphere is equal to 4/3 pi r cubed, where r is the radius of the sphere. So let's say we need to calculate the volume of a sphere with a circumference of 10 centimeters. And then we want to find the volume of the sphere in centimeters cubed. Okay, so why did I tell you the circumference? Well, it's really hard to measure the radius of a sphere, but what you guys can do is you can take your tape measure. So these tape measures in your lab kit are paper like this, and they're made specifically for doctors to be able to measure the circumference of a head or the circumference of, your bicep or any other body part. And then once the doctor's finished with them, you can toss them away. Okay, so we're going to use this to find the circumference of your sphere, your ping pong ball. Okay, and so you'll find the equator, essentially, of your ping pong ball, and you'll just go around, and then from that you can get the circumference of your sphere in centimeters. Okay, so let's say that this ping pong ball had a circumference of 10 centimeters. So the equation for circumference is 2 pi times the radius. So once we've got the circumference, we can use this equation to get the radius of our sphere. So in this case, we've got 10 centimeters is equal to 2 pi r. So if we divide both sides by 2 pi, we find that the radius of this sphere, 1.59 centimeters. Okay, so easy. Now I take that radius and I plug it up here for the volume of my sphere. So the volume is equal to 4/3 pi times my radius, 1.59 centimeters cubed. Okay, and then that turns out to be 16.8 centimeters cubed for the volume of my sphere. Now, what if I asked you to find the density of an object? Okay, the density of an object is represented by the Greek letter rho, lowercase Greek letter rho. Density is equal to the mass of that object divided by its volume. So pay attention to the unit. I'm going to ask you for units of density, because there are two standard ways you can report units of density. You could write density in units of grams per centimeters cubed, or you could write density in units of kilogram over meter cubed. Okay, and so in one of the pre-lab problems, I'm going to ask you to find the density of a sphere with a given mass and radius, and you need to report your answer for the density of that sphere in kilograms over meter cubed. So if you're going to get the density of something in kilograms over meter cubed, you've got to get the mass in kilograms and then the volume in meters cubed. So here we found the volume in centimeters cubed. So for the radius, instead of using centimeters for the radius, you would use meters here for the radius. So you could get your volume instead in meters cubed, and then you could use that to get your density for your object in kilograms per meter cubed. For another part of this lab, you're going to have to find the volume of a hex nut, one of these, and they are also in your lab kit. Okay, and so this is a really weird shape. How do you find the volume of it? Now, I know that you all have had geometry at some point in your lives, so we'll refresh our memory here. So if you neglect the hole in the center of your hex nut, okay, this is what we call a hexagonal prism. So you have a hexagon with 6 sides, and essentially you're taking a bunch of these little thin hexagons and you're stacking them up on each other, a height of h. Okay, so to find the volume of this hexagonal prism, you take 3 square root of 3 divided by 2 times a squared, where a is the length of the sides here of your hexagon, and we're going to assume that all of those sides are the same length. So this first term here, the 3 square root of 3 over 2a squared, that is the area of what we call a regular hexagon. So that would just be like the area of the top of this prism here. Okay, and then you stack a bunch of those hexagons up, a height of h, and then that gives you the volume of your hexagonal prism. So that's this right here. Okay, so then you know your nut has a hole in the middle. So what you can do to find the volume of this is you find the volume of a whole hexagonal prism and you subtract off the volume of that empty hole in the middle. And so that hole has a height h, but it's a circle. So that's the volume of a cylinder. And the volume of a cylinder is pi r squared. So to get the volume of this hexagonal nut, what we're going to do is take the volume of a hexagonal prism and subtract off the volume of a cylinder that represents the hole in the middle here of your hex nut. And in doing that, we get the volume of our hex nut itself. So we're taking this whole bit, subtracting off the hole in the middle, and that gives us the volume for our hex nut. Okay? So, and then to measure your hex nut, again, take your meter stick, or your measuring stick here, or your measuring tape, or you could use the centimeter side of your protractor, and you find this length A. Okay, so that's the length of the sides, and then you find the height h, essentially how tall is your hex nut. Okay, that's your quantity h, and then to get the radius of this cylindrical hole down the middle, well, you could find the diameter of that hole, and then if you divide it by 2, that gives you the radius of that cylindrical hole in the middle. Okay, so let's try a problem. So let's say that I want to find the volume of a hex nut, and I know that the length of my sides here, A, are each 1 centimeter, and I know that the height of my prism here, the height of my nut, is also 1 centimeter, and I know that the diameter of the hole in the middle of my nut is 1 centimeter, so that means that my radius of it is 0.5 centimeters. Okay, so we can use this to get the volume of my hex nut, which will be equal to 3 square root of 3 over 2 a squared, so 1 centimeter squared, times the height, 1 centimeter, minus, I've got the volume of my cylinder, pi, the radius of it, 0.5 centimeters squared, times the height, 1 centimeter. Okay, so we've got, in both cases, we've got a centimeter squared times a centimeter. That gives us units of volume, which is a length times a length times a length. So our answer is going to be in centimeters cubed. So this portion right here is going to give me 2.598 centimeter cubed, and I'm subtracting off 0.785 centimeters cubed. So then the volume of one of my hexagonal nuts is 1.813 centimeters cubed. Okay? Now, what if I asked you to report the volume in meters cubed? Okay, so how do you get from centimeters cubed to meters cubed? Well, let's do that. So we've got 1.813 centimeters cubed, and I've got to get it to somehow meters cubed. So I have to multiply it by a conversion factor. So think about a meter. 1 meter is 100 centimeters. So if I'm going to find the volume of a cube of length 1 meter, width 1 meter, and height 1 meter, that's the volume of a cube. That's 100 centimeters by 100 centimeters by 100 centimeters. So 1 meter cubed is 100 centimeters times 100 centimeters times 100 centimeters. Okay, so that gives me my centimeters cubed on the bottom. So to get my answer meter cubed, I have to take 1.813 and divide it by 100 times 100 times 100. And these centimeters, because there's 3 of them being multiplied together, that's going to cancel out with the centimeter cubed. And so then that gives me a volume of 1.813 times 10 to the minus 6 meters cubed. So that's how you could convert from centimeters cubed to meters cubed in case you need to be able to do that.